Let f of x be a function having derivatives of all orders, okay, where x is greater than 0, so that f of 3 equals 2, f prime of 3 equals negative 1, f double prime of 3 equals, and triple prime of x, okay? Which of the following is the third degree polynomial of f of x about x equals 3? Okay, so this is basically saying find the Taylor series of something. And they give us a whole bunch of data, and we're kind of expected to plug it in. So this is kind of like giving us a very complicated problem and then giving us most of the work already done. We just have to put it together. So first thing to do is remember the formula for a Taylor series. So it's probably something kind of like this. There we go. That feels right. Okay. So it looks like in this case a equals 3. Okay. So, maybe we'll start writing things out and see where we go from there. So f of 0 is just f of normal. So it's the function, i.e. not a derivative. So this right here, it's not a power or exponent or something like that. It's a, maybe it is, no, not an exponent, superscript. It is a superscript, but not an exponent. And that's the number of derivatives you've taken. So f of 0 in this case will be no derivative, just the function. So f of 3 times x minus 3 to the 0 over 0 factorial plus f prime of 3 times x minus, that's a terrible x. I am ashamed. There we go. Moderately better. Marginal. Okay. Oh, running out of room. We're never running out of room. This is an infinite whiteboard. Infinite real estate. Though there's probably some sort of like memory limit associated with this. I don't know. I wonder how big it can get. All right. So, almost done. Okay. So we wanted a third degree. Yep, because it looks like everything goes up to 3. Whoop. And there we go. So now I'm just going to start plugging in numbers. Hopefully it'll take up less room once I start actually plugging in numbers. So f of 3 is 2, right there. X minus 3 to the 0 is 1, because anything to the 0th power is 1. 0 factorial is 1. By convention. There's no real logical reason for that, other than it works, and it seems to work well. So that is why. Do x minus 3 to the first, so I'll just leave off the 1. And we're still divided by 1 factorial, which is the same as 0 factorial, which is 1. f of 3 equals 6. X minus 3, now we're going to do squared over 2 factorial, which is 2. 2 times 1. Did I forget the factorial? Factorial. Plus 12 times x minus 3 cubed over 3 factorial, which is 3 times 2 times 1, which is the same as 3 times 2, which is 6. Okay? That doesn't seem so bad so far. Simplifying again, 2 minus quantity x minus 3. Okay? Plus 3. 3 times x minus 3 squared plus 2 times x minus 3 cubed. Now let's see if we want to... Okay, so it looks like they're okay with leaving the 2 and the 3 separated. And we could take the x minus 3 squared and FOIL that and then expand it out more. But they're not asking for that, so we're good. Okay, so we got a 2, a negative, a 3, It's supposed to be a 2 here. There we go. And a 2. So this looks like the one right there. So that has the wrong. So these are the same. That's wrong. That's wrong. That's wrong. Now it's possible that for these are probably either the Maclaurin series, where A is assumed to be 0, which is not the case here because we're specifically told that x equals 3. Or when they expand these out, the squared and the cubed, maybe they magically kind of sort of work out, but I doubt it. I think they're just trying to confuse you by saying that it's a Maclaurin series where x equals 0. About x equals 0. So the answer for this one is right here. Yeah, I'm not going to read that out. So to backtrack, the idea here is they tell you to do a Taylor series, and they give you most of the data so you don't have to derive it yourself, which is nice. But you do have to have a certain level of fluency to be able to pick it up midstream and run with it. And that is how you do this kind of problem.